question number 2. They are telling us that in the diagram below, we have Q, which is 15, and M is the center of a larger circle, which touches both the x-axis and then the circle that is centered P. The circle with P has the y-intercept at A. Okay, we can see that. And it has an equation of this much. All right. If that is true, they want us to determine the equation of the circle with center Q in terms of x, y, and m. 1 mark. So guys, we know that the general equation of a circle is x minus a squared, and then y minus b squared is equal to r squared. Remember, the minus can be a plus, depending on the coordinates. Now, what I'm gonna do, I'm just gonna say x, since the 15 is positive, I'll change the sign. I'll say x minus 15 squared plus y minus m squared is equal to what is our radius? Our radius is 8 units. So 8 squared is a 64. So that is 2.1.1. Then determine the value of m, 2 marks. Value of m. All right, so there was a statement that was given to us. Number 1, they told us that the larger circle touches the x-axis. That is important. Then they told us that the radius of the circle is 8 units. So if this is 8, which means even if I try to drop a line, okay, that is parallel to the y-axis, the distance there is gonna be 8. And remember, the x-axis is also named as y is equal to 0. So which means we are counting how many units from the 0 line? 8 units to the center. So which means m is automatically 8 units. Okay, so saying m is going to be 8. Then if that is true, then they want us to get the length of PQ. PQ. When I look at the equation of circle P, the coordinates are 3 and 5, not 3 and 3, okay? But the radius is 5. Since r squared is 25, which means the radius is 5. So which means from here up to there is 5 units. But we said from the circumference to the center of the big circle is 8. So guys, we don't need to find, or we don't need to use the distance formula in this case. We can just plus the radii. So 5 plus 8, and then that gives us 13 units. Okay, so if you have trust issues, we could probably use the distance formula just to affirm or confirm that indeed what we're talking about is correct. Okay, you get your 13 units there. Then if that is true, then they want us to get the coordinates of A. Coordinates of A. So since A is the y-intercept of circle P, and we already have the equation of x minus 3 squared plus y minus 3 squared is equal to 25. One thing we know about the y-axis is that x is always a 0. Okay, so what I'm gonna do, I'm gonna get that equation of that circle, x minus 3 squared plus y minus 3 squared. And I'll find the square roots on either sides. Okay, so y minus 3 will give me a plus or minus 4. Okay, I don't want to go that route of opening up, but you're still allowed to do that. You find the quadratic, and then you get your 2 values using the quadratic formula, all the factors. Okay, so my y is gonna be plus minus 4 plus a 3. So the first y is either 4 plus 3, which is a 7, or -4 plus 3, which is -1. Now, the question wants the coordinates. It wants the coordinates of A. So since we have two values, you can see that the smaller circle is meeting the y-axis as two points. Okay, so now we need to choose selectively, or we need to be very logical. Okay, so I'm gonna say that my A is gonna be 0 and 7, since 7 is on the positive side. Okay, that is done. Then 2.1.5, they want us to determine the equation of a tangent to the circle with center P at point A. So one thing we know about a tangent is a line that touches the circle, that touches any graph at one point. And from our circle geometry, we know that the radius or diameter and the tangent will always be perpendicular. So since we have our coordinates of A, which is 0 and 7, we can get the gradient of PA. Okay, so we're saying gradient of PA. This is question number 2.1.5. 2.1.5. So gradient of PA, that's going to be change in Y over change in X. So when I look at my coordinates, so I'm gonna have 7 minus, okay, so 7 minus 3 over 0 minus 3. Okay, so 7 minus 3 over 0 minus 3, that's gonna give me a -4 over 3. This is the gradient of the radius, okay? But the radius and the tangent, we said will be perpendicular, which means the gradient of the tangent is going to be 3 over 4. Remember what we said about perpendicular lines, that m1 times m2 must give us -1. So I'm just dividing -1 with this, give me 3 over 4. Then I'm gonna say at A, which is 0 and 7. So my Y is gonna be 3 over 4x plus a 7. I don't need to use that formula since I know that this A is also acting as the Y-intercept of my tangent. Okay, guys, so that is 2.1.5. All right, then 2.2, they're telling us that two other circles are drawn or are given. Okay, one circle has a center K with this equation. The other has a center T, but with this equation as well. Determine the center and the radius of a circle with center K. And so what we normally do is we complete squares in this case. Okay, so I don't know how one would approach this, but I would always prefer moving the 12 that side. So I'll have x squared minus 6x plus y squared plus 4y is equal to 12. Okay, then let me just write to this side. This is 2.2.1. Okay, we said x squared minus 6x plus y squared, okay, plus 4y is equal to 12. Okay, guys, so we're gonna open two brackets. Okay. Just watch what I'm gonna do now. Okay, so we're gonna get x, and then let's keep the sign to minus, and then we get a half of 6, which is a 3. We square that. Okay, we know that 3 squared is gonna give us a 9. So we're gonna plus a 9 somewhere here. Then let's go to the y. Let's keep the sign, which is a plus. Then a half of 4 is 2. We square that. So we know 2 squared is 4. So I'm gonna put it that side, plus 4. as well. So which means I'm having x minus 3 squared plus y plus 2 squared is equal to 12 plus 9 plus 4. Is that true? Yes, which is a 25. So which means the coordinates of k are gonna be 3 and negative 2. I need to switch the signs inside the brackets. And then my radius will be the square root of this 25, which is 5 units. Okay, so guys, that is that, because this whole thing represents the r squared. So square root will be 5 units. So 2.2.1 has been answered. Then 2.1.2, sorry, 2.2.2. So we said this is 3 negative 2, and then our r is a 5. Then they want us to get the distance between the centers K and T. The distance between the centers. Are these circles touching each other? No, we don't know. We don't know for sure. So we know that the coordinates of T are 12 and 10. And we know that the radius of the circle T radius is going to be 10 units. Ne? So what we need to know, use the distance formula so that we just save time. So KT is going to be the square root. I'm going to say 12 minus 3 squared plus 10 minus 2 squared. I'll punch that into the calculator. This is 12 minus 3. Come on. 12 minus 3 squared plus, that's 10 minus 2, which is a plus 2. And I square that, I'm getting 15 units. Okay. So answer for 2.2.2 is 15 units. That's from the distance formula. Now, they're asking us at how many points do the two circles intersect? So guys, remember, if you have two circles that are having K and T, if we get the distance KT, if this distance is equal to the radius of K plus the radius of T, then this is gonna be just touching at one point. Then if our KT, the distance we just found out, is greater than the radius, the distance of the radii, then which means they are not touching. Okay. And then if our KT is smaller than the radius, which means the circles are touching at 2 points. Okay, so we have our KT. Can we get the radius of K plus the radius of T? Remember we said radius of K was a 5, radius of T is a 10. So that is 15. So the two are equal. And we said for as long as they are equal, the circles are touching at one point. Therefore, the circles touch at one point. Okay, so at how many points do they touch? So we said 1 point. The motivation is going to be this. KT is equal to RK plus RT. There we go. So that would be our motivation, and that would be question number 2.